3D modeling using coding, and art from mathematics? I'll show you how with Blockscad. For quite a few years now, there's been something called OpenSCAD. It uses coding to generate 3D shapes, and it's very popular with some people. One key advantage is the ability to have variables so you can customize your creations with a drop-down menu. Recently, I've discovered Blockscad. It builds on OpenSCAD by using a scratch-style drag-and-drop interface. The good news is it's a great way to learn OpenSCAD, and it's suitable for children as well. Let's see what we can do with it. Once we open up Blockscad, this will be the screen that we're presented with. The interface is pretty simple. On the left-hand side, we have a bunch of categories with preset commands. We have an area to drop these commands, and then on the right, we have our output where we'll see our 3D model. Let's experiment with some of the basic ones to see how it works. After you drag these out, nothing will happen until you hit the render button, so let's do that. Okay, something simple like this, it appears quite fast, and you can see here we have a sphere, a cube, and a cylinder, except they're all on top of each other. You can see it's made the 3 different shapes. If we want to move them around, what we need to do is come to the Transforms tab, and then let's try something like Translate. Let's move our sphere 50 mils to the side, and try this again. Okay, now we can see it's becoming a little bit clearer. Here is our sphere. Our square is in the middle of our cylinder. Let's try another one. Let's come to Transforms and then go to Rotate. Okay, you can see now we have 3 distinct shapes. And even though these aren't attached to each other, it just works through and makes everything that we have in this area. So you might be thinking, this is pretty useless, but let's explore Blockscad with something a little bit more world useful, like a phone cover. I'm going to start by dropping out some cylinders, and then I'm going to use my Translate tool to move them into different positions. So the first one, I think I'm going to move up 50 and minus 25 to the side. Put our grid on so we can see what's happening. I'm going to right click and I'm going to duplicate this, and the second one is going to be very similar, except it's going to be positive 25. I'm going to duplicate once more, back to minus 25, and this time minus 50. We'll duplicate a final time and do our last combination, which is positive 25 minus 50. Okay, you can see I've set up what could be the 4 corners of a phone case, but how do I join them all up? Well, that's actually easier than you think. If we come to our set ops, we have a bunch of these different commands here. So some of them are obvious, like union and difference. That's how you add things together or subtract them. But the one we're going to experiment with is called hull. Everything we put into here will be shrink wrapped. So wherever the extremities are, it's going to join them up for us. So I'm going to hit plus and add enough for all of these. Actually, I'll do it with just 3 so you can see exactly how it works. You can see that it's shrink wrapping it and everything is being joined up. So let's hit the plus and add one more. You can see we have the basic shape of a phone here. Let's save some time and duplicate this one more time. And this time we're going to make our values just a little bit smaller here. At the moment we won't notice anything different has happened because we've got 2 of these shapes, one slightly smaller but directly inside of each other. This time, however, we're going to come up and change it to something like 2, which is going to translate it up off the bed just that little bit. And now when we render, we should see one poking out just past the other. Now, it's pretty useless at the moment, but what we're going to do is come to setups and go to difference. And we're going to start with our one up the top, and then we're going to minus our one down the bottom, which means it's going to use the second one we did to cut a hole in the first. Let's try that. Okay, we're starting to have something a lot more useful here. One of the really nice features that we can do is import an STL. So let's try that now. At the moment, if we hit render, it should create this STL somewhere on the bed, but let's go one step further and say that we want to minus the shape from the phone case. Let's drop this in here and hit render and see how it looks. Okay, you can see that it has removed the STL that we imported from the phone case, and very quickly we've created something interesting. We can, however, do even more than that by coming to translate and then moving this into position. So let's move it on the Y direction. Let's try something like -30. Okay, that's a much nicer position. Now, one of the real strengths of this program is we can have variables. So let's pull out this top one. And drag out a number to go in its place. And we might rename this one from item to logo position. Okay, now back under variables, we're going to drag out logo position to our Y, and we're going to hit render one more time. See, it's moved it back to the middle, but now up the top here, if I change this to a completely different value and hit render again, it moves the position on the model. So this is how they achieve what they do on the customizer on Thingiverse. Basically, you have in your OpenSCAD code a bunch of variables, and then you place them inside the code, and you can use them to customize and adapt your geometry depending on your needs. We might come to our code tab, and this is the OpenSCAD code that will be generated. If you're new to this, it's going to be a lot harder to write this type of code than it is to do it with the blocks. If you're happy, you can come up and save your project, and it will save an XML file with the title that you've put in. For me, I don't have one, so it's called untitled. You also have the option of saving the OpenSCAD code to your computer, which is perfect for uploading to Thingiverse if you'd like to make something that works with the customizer. For now, however, we're going to try something completely different. So we've covered doing regular 3D modeling with Blockscad, but let's try something completely different and go for some beautiful mathematical artworks using these command blocks here. Okay, we can start with any 3D shape that we want. We might start with a cube. The crux of what we're doing is going to come from the loops. It's a key programming concept, and Blockscad and OpenSCAD can apply it really well. So let's come to transforms and then go to rotate, put our cube inside and see what we can do. What this loop is saying, it's going to count from 1 to 10 in steps of 1. And if we hit render, it's not going to really look like anything. What we're finding is it's doing 10 squares on top of each other. So what we need to do is, we can see this I variable here. If we come to our variables, it's automatically created this I, and then we can put it in any of these blocks that have the same shape. If we hit render, we should start to see some differences. Okay, it's very subtle here, but what it's doing is starting to rotate the cube each time by 1 degree. Let's up this number so it's more obvious what's happening. So it's reproducing the cube 180 times, and each time it's rotating it around this axis by 1 degree. Let's try moving the eye to one of the other axes and hit render and see how that looks. Okay, you can see that we're rotating around the Z axis here. Where we can start to make this look really cool is to introduce translation as well. So instead of this cube being in the center and rotating around this vertical line here, what we can do is move it slightly offset from the middle, and then we should get a much better effect. Let's try 20. Alright, this is already looking a lot more interesting, but what happens if we rotate it in more than one direction? Let's duplicate this eye and put it under X as well. Okay, we can start to get a really interesting shape here. we have all of these fine little lines here, but they're kind of getting lost between each other. So how about, instead of counting up by 1, which is going to have 1 degree of rotation, we count up by 5. Immediately, because there's less steps, it programs a lot faster, but we can see that the steps are a lot more coarse and our pattern is a lot more obvious. Let's step it up one more time and duplicate this and put it in the Y as well. Okay, we're starting to get some pretty funky shapes here. One thing we can do, instead of rotating each one evenly by eye, is we can come to our math and we can try some of these different blocks here. So in the Z direction, instead of just doing it by eye, I'm going to do it by eye times 2. So therefore it's rotated double the amount as it is for the X and Y axis. We immediately get to see some really interesting shapes here. Let's try upping this all the way to 360 degrees of rotation. And we're getting some really, really nice shapes here. Wow, that is a really cool shape. I'm really happy with that. Let me show you some of my other experimentation that I performed. This one here makes a really cool knotted effect. It looks quite mesmerizing as I rotate it here. And the key to it is using the 3D text from the text tab, and I use the letter X. Basically, I'm applying what I showed you in the last example, except Z is rotated by 3 times. This one I really like because it's a really simple idea, but the implementation is really effective. Got this beautiful reflective pattern on the inside, and basically it's a combination of what I've showed you so far, except it actually has 2 loops. It has one for J and one for I. And if you look, we rotate for one of the loops on I, and then the next loop on J, and then we rotate on J a 3rd time. So not only do we have it rotating around the middle, which is one of the loops, we have them rotating on themselves, which is the 2nd loop. And that's how we get this great effect here. This one here is made by using a sine wave to modify our I counter. If you know a sine wave, it goes up and down like an ocean wave. So we can get some really cool effects by using that one. This one's quite like a ring, so I thought, why not actually hollow out the inside so it could be a ring design. So you can see here that I have one disabled. If I enable this block and render, I've managed to align and size this cylinder to go through the middle. I can then cut it out, but you're probably thinking it's a pentagon. It's not actually a cylinder like it's meant to be. That's because we have our smoothness set to low. Once you think you've trialed everything and you're ready to slow down the program because you're going for maximum quality, then turn it to high and hit render again. Let's look at the difference on this pentagon to see what becomes. Okay, that's much more like it. So what we might do is come to our setups and once again come to difference. And we're going to start with the ring and minus the center, hit render, and it should cut it out for us. Okay, that is a pretty cool design, I must say. Now the same technique of cutting out something afterwards can also be used to give a flat bottom to something ready for 3D printing. Let's try that now. So if I zoom out here, you can see I have a very large box and I've positioned it so it just intersects with the bottom of the ring. I've colored it yellow so it's clear, and by putting the cube on centered, it means we're positioning it from the middle of the shape instead of from the corner. So all I really have to do is get my translation correct. To know the right direction, you can zoom out and pay attention to these labels here. We can see that this one is X. Therefore, I know I'm putting in a number on my translate X to move the box up and down in this direction to cut off what I want. Now that I know that it's in position, I can drag it into my difference minus command, put up the quality at high and hit render again, and I'll have something ready to print. Alright, the render is finished and we can see our excellent shape on top is preserved, but we have a nice flat base for 3D printing. If we're trying to print it from any of these, you'll probably find that you need far too much support material and the pattern is ruined anyway, so far better to give it a flat base and do it right the first time. If you create something that you're really happy with and you want to put it on Thingiverse, you need to come to code and then copy and paste this code here. You'll notice the option to tick that it's an OpenSCAD file. This is where that code will go. What we're going to do is come to generate STL and export some of our favorite ones ready for 3D printing. Unfortunately, there's a bug with Blockscad in which it doesn't generate watertight STLs. You can, however, copy and paste the same code into OpenSCAD and generate your STLs there. Let's get printing. I hope you agree that Blockscad can be a great way to learn mathematics through art, design, and even 3D printing. Stay tuned to learn more interesting ways to expand your technological knowledge. G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.